All right, let's go ahead and start going over the warm-up real quickly. For here, we have what kind of angle relationship? Who can recall, is this complementary, supplementary, or vertical? Emmy? Vertical. They are vertical angles, angles that are formed by the intersection of lines, and then they are directly across from each other, and they are congruent angles. They are equal in measure. So that means when we create an equation, we're going to write x plus 7 for this first angle that we see is going to be equal to 100, because again, these are vertical angles. So I'll even write this down, that they are vertical. Vertical means that they are equal to each other in measurement. So once we have the equation written, all we have to do is solve by doing the inverse of addition. And then the inverse of addition is to subtract. So when I subtract 7 from both sides, remember the 7 is going to cancel out here. And then what is 100 minus 7 going to give us? 93. So x is going to be equal to 93 for problem number 1. All right, for problem number 2, who can raise their hand and describe what kind of relationship this is? Abdullah. Complementary. Complementary forms that L shape. You have a combination of different angles that are going to form the L shape. Okay, complementary means that when you add them together, it should equal how many degrees? 90. So by adding, going to come out to 90. So x plus 73 is going to be equal to 90 degrees. That's the equation that I make when I see a set of complementary angles. Okay, to solve, all I have to do is subtract 73 from both sides. Those 73s are going to cancel each other out. And then what is 90 minus 73 going to give us? Huh? Not 27. Tiana? 17. Okay, 17. All right, let's take a look at problem number 3. For problem number 3, again, we've already seen these. We already talked about it before. They are the vertical angles, right? We've got those intersecting lines. Okay, we have those intersecting lines, so these are vertical. That means that the measurement of is going to be equal to the angle, which is 62. So 2x is going to be equal to 62. In order for us to solve, in this case, we're just going to divide both sides by 2. Right? Inverse operation of multiplication is going to be division. So we'll divide both sides by 62, and we're going to get x is equal to 31. X is going to be equal to 31 for that case. All right, for our last one, what relationship is this one, Jeremy? Supplementary. Okay, it forms that straight line. Forms that straight line, so it makes them supplementary. So I'll even write that down. They are supplementary. Oops. And supplementary angles, when we add them together, so if I add x and 35 together, what is it going to equal? For supplementary angles, when we add the two angles together, what will it equal? Who said that? Say it louder. 180. It's going to be set equal to 180. Okay. Inverse operation of addition is to go ahead and subtract. So we're going to subtract 35 from both sides, and we'll get that x is going to be equal to 145. Okay, it's important that you know those relationships, because we are going to be using those relationships again tomorrow, but we're going to be using them with a little bit more complex equations, two-step equations. Okay, so if you turn your papers over to the back, we're going to talk about the rules for solving with two-step equations. Okay, so we already know one-step equations. We understand that pretty easily. You do inverse operations. But when it's one step, you only have one operation that you're having to do an inverse of. With two-step equations, you have two operations that you are doing the inverse of. Typically speaking, you're doing an inverse operation to addition and subtraction, and you're doing an inverse operation to either multiplication or division. Those would be the two steps. So you're going to either add and multiply, or you're going to subtract and multiply, or you're going to add and divide, or you're going to subtract and divide. Okay, so you've got two operations that you're going to be performing. So the first thing that you have to do is, well, first of all, you need to understand which numbers up here are your coefficients and which numbers up here are your constants. So remember, when we talk about a constant is a number that is by itself. It is not attached to the variable. So in this case right here, this minus 11 is the constant. So when we're talking about a constant, you're performing the inverse operation to the constant. That's what we're talking about. We're talking about the number that does not have a variable literally attached to it, either side by side with it or, below it or on top of it. It's not got any kind of attachment whatsoever. It's independent. Okay, the coefficient or divisor, because it could be a divisor as well, your coefficient is attached to your variable. Your coefficient is going to be attached to the variable. Okay, a divisor is what you're dividing a variable by. That should be easy to understand. So for here, when we're talking about steps of solving, the first thing that you want to do, step 1, you want to go ahead and do the inverse operation to the constant. That means you're either going to be adding or subtracting first. You're either going to add or subtract first in that problem. So if we've got that problem, 2x minus 11 is equal to 5, I need to go ahead and get rid of the constant. So instead of subtracting an 11, what's the inverse going to be? Adding. Okay, adding an 11. So my first step in this process is to add an 11 to both sides. I need to do it on both sides of that equal sign. By doing so, then I'm going ahead and I'm getting rid of the constant on the left side. I can box that off and it's completely gone. And what I'm left with is 2x is now equal to a positive 16, because 5 plus 11 is going to give me 16. That brings me down to my second step. My second step is basically finish off this one-step equation by doing either multiplication or division. So think of it like operations. Usually with order of operations, we do multiplication and division first, right? And then we do addition and subtraction. But when we're solving for something, something is missing. So it's kind of like, how many of you have ever lost like your phone, misplaced your phone or your house keys or something like that? All right, when you misplace your phone or your house keys or something that you've lost, you go back through your steps, right? Where did I have it last? Okay, where was I just at? Or I was just in the kitchen. Let me check the kitchen. Okay, it's not here. All right, where was I after the or before the kitchen? Oh, I was in my bedroom. Let me go back to my bedroom. Let me see if it's in here. You kind of retrace your steps backwards, right? It's the same thing with solving equations. You're retracing your steps and working backwards through the order of operations. So you're getting rid of the addition and subtraction first, which is usually the last thing you did. Then you're getting rid of the multiplication and division, which is usually the thing that you do first. Okay, you're going backwards through it. That's how you solve. Okay, so for a problem like this, again, we were left off with 2x is equal to 16. We're now going to go ahead and what? Are we going to multiply or divide? divide. We're going to divide both sides by 2, and that's going to get the x by itself. What's x going to equal? What's 16 divided by 2, Kyle? 8. Okay, so we'll get x is equal to 8. So get rid of addition and subtraction first. Get rid of multiplication and division second. Let's do a couple practice problems. Let's take a look at this one. 2x plus 3 is equal to 23. 2x plus 3 is equal to 23. Again, the first thing that I want to do is get rid of my addition and subtraction. So here is my constant. This is what I happen to be adding. I'm adding 3 right now. So what is my inverse operation? Kyle? Subtraction. So we're going to subtract 3 from both sides. I'm going to go ahead and subtract 3 from both sides. Okay, by subtracting the 3s are going to go ahead and zero out. I'm still left with 2x is now equal to what? What is 23 minus 3? 20. All right, I have 2x is equal to 20. What do I now need to do? What inverse operation am I going to do next? Divide. What am I dividing both sides by? 2. We're going to divide by 2. So we're dividing both sides by 2. What is 20 divided by 2? 10. So we get x is equal to 10, and there's our final answer. X is equal to 10, and we're done. For 2, it says x over 2 plus 5 is equal to negative 2. X over 2 plus 5 is equal to negative 2. Who can raise their hand and tell me what inverse operation do we need to perform first? Jeremy? Subtraction. What are we going to subtract from both sides? 5. Okay, we're going to subtract 5 from both sides. And guys, you need to make sure that you're utilizing those calculators. Okay, you need to make sure you're utilizing them because some of you are still convinced that you can do this in your head, but you keep doing it wrong. Please use the calculator. You're going to subtract 5 from both sides. These 5s are going to go ahead and cancel out. That's going to leave you with x over 2 is now equal to what? What is negative 2 minus 5? Negative. Okay, again, if you're using those calculators, you shouldn't even have any chance of getting that wrong. You should just literally be typing in negative 2 minus 5. That's going to give you negative 7. Okay, from here, what inverse operation do we now need to perform, George? What inverse operation are we going to perform now? From here, look up at the board. What are we going to do? Multiply. And what are we going to multiply both sides by? 2. We're going to multiply both sides by 2. So when we multiply by 2 on the left side, 2 times x divided by 2. So multiplying by 2 and dividing by 2 cancel each other out. So we're left with just the x. And then we're going to multiply the negative 7 times 2. Negative 7 times 2 is going to equal negative 14. So there's our answer, negative 14. Okay, get that copied down, and let's go on to the next page. All right, let's take a look at problem number 3. For problem number 3, Angel, what is the inverse operation that we need to perform first? Angel, I called on you, hun. What inverse operation do we need to perform first? Addition. What are we going to add to both sides? 15. Thank you. You're going to add 15 to both sides. These values are going to go ahead and get canceled out. We're going to add 15 to both sides of the equation. These 15s are going to go ahead and get canceled out. Okay, that leaves us with 2n on the left side of the equal sign. And then what is negative 29 plus 15? Everyone should be doing this in their calculator. You're going to have to do this on your own eventually. Negative 29 plus 15. Negative 14. Thank you. Negative 14. Negative 29. So think about it. I owe $29 to my friend. But I went ahead, I gave them 15. I paid back $15. So I still owe them $14. Okay? Think about it as in terms that you understand. You guys understand when you owe somebody something or borrowed something from somebody and you owe them that amount back. You guys understand that. So think of it in that term. Okay, last step. Okay, Ron, what do we have to do now? Divide. And what are we going to divide both sides by? 2. Good. We're going to divide both sides by 2. So we're going to do 2 divided by 2, which cancels it out. Doesn't equal 0, it just equals 1. It cancels it out, so equaling a value of 1. And then we're going to do negative 14 divided by 2. As soon as it catches up. Sorry, guys, it's frozen. Give it a second. For problem number 4, we've got 8 plus x over 4 is equal to 17. 8 plus x over 4 is equal to 17. So this one's written a little bit differently. It's written a little bit different, but we still, again, like I said before, with step 1, we've got to focus on the constant. Which number up here is the constant? Michaela? 8. 8 is the constant. So we need to focus on getting rid of the 8. We need to focus on getting rid of the 8. So right now, is the 8 a positive or a negative? It's a positive. So it's almost like I've got a little plus sign in front of it. It's like I've got a little tiny plus sign right in front of it. So the inverse of that is going to be to subtract. I'm going to subtract 8 from both sides. There's a reason why I say to focus on that, because eventually this might be a minus sign here, but you would still subtract because you're subtracting to get rid of the constant, not based off of what this one is going to be. And you'll see an example of that in the next problem. Okay, we're going to subtract 8 from both sides. The 8s are going to cancel out, and we are now left with a positive x over 4. So we have x over 4 is equal, and what is 17 minus 8? 9. Okay, next step. The next step is to go ahead and multiply both sides by 4. We're going to multiply both sides by 4 to get the x isolated. So multiply by 4 on the left side, multiply by 4 on the right side. And x in this case is going to be equal to 36. Now, what I was meaning before is if you look at problem number 5, a lot of people think, oh, hey, it's 5 minus 3y. I'm going to add. But if I add 5 to both sides, does that get rid of the 5? No. What's 5 plus 5? 10. It doesn't get rid of it. So when we're focusing on getting rid of the constant, you got to focus on what the constant has a sign for, what sign is in front of the constant, what sign comes before the constant. And right now, that 5 is a positive 5. So I'm going to put a little plus sign in front of it. So the only way that I can get rid of that 5 is to subtract 5 from both sides. Please make sure you're paying close attention to this one. This is a very important problem right here. Number 5 is a very important problem because a lot of people tend to mess it up. So I'm going to say it one more time. That minus sign does not belong to the 5. It belongs to the 3y. The minus sign does not belong to the 5. It belongs to the 3y. It's frozen again. So we're going to go ahead and subtract 5 from both sides instead. So I'm going to subtract 5 from 5. I'm also going to subtract 5 from the 20. So I'm going to do 20 minus the 5. These 5s are going to go ahead and get canceled out. 20 minus the 5 is going to leave us with 15. And that's going to be equal to, and here's what's important, that minus sign now has to come down like a negative sign. So it comes down like a negative 3y. Comes down as a negative 3y. A lot of people forget that minus sign, but that minus sign is going to come down and it's going to act like a negative now. Now, in order to get the y by itself, I have to divide. And what am I going to divide both sides by? Not 3. No. Negative 3. I have to divide by the number. The number is a negative 3, so I need to divide by a negative 3. Okay, we're going to divide both sides. Divided by negative 3 is going to come out to a negative 5. So we get y is equal to negative 5, not a positive 5. Comes out to a negative 5, not a positive. Your own in just a few minutes. Constant. And a constant right now has a negative sign in front of it or a minus sign in front of it. So we're actually going to add 2 to both sides in order to get rid of that constant. We're going to add 2 to both sides in order to get rid of the constant. What we're going to bring down in the problem is a positive 4h. So 4h is now going to be equal to negative 4 because negative 6 plus 2 is equal to negative 4. We're then going to divide both sides by a positive 4. We're going to divide both sides by positive 4, and we'll get h is equal to negative 1. H is going to be equal to negative 1. Okay, for problem number 7, again, number 7 is similar to a problem like what number 4 and number 5 were. We want to get rid of the constant, and the constant right now is a 5. Okay, so what we're going to be doing is we're going to subtract 5 from both sides. George, head up, please. Even though it's a minus sign, even though it's a subtraction problem, we're not subtracting the 5 in the problem. We're actually dealing with a positive 5. So the inverse of a positive, subtract 5 from both sides. Those are going to get canceled out. Okay, that's going to leave us now with a negative 7x is equal to 14. Negative 7x is equal to 14. We're then going to go ahead and divide both sides by a negative 7. George, second time telling you, head up. Got to keep the head up, hun. We're going to divide both sides by a negative 7. George, lift up your head. 14 divided by negative 7 is going to give you a negative 2. So we get x is equal to negative 2 for that one. Okay, problem number 8. Problem number 8. Fraction shouldn't be a big deal. It doesn't matter that there's a fraction. It's still the same exact process. We're first going to go ahead and add 7 to both sides. so that we can get rid of those constants. We're going to add 7 to both sides just to get rid of it. That's going to leave us with 2/3 x is now equal to 8. Then we want to get rid of that coefficient, so that means we're going to divide both sides by 2/3. We're going to divide both sides by 2/3. So if I divide 2/3 by 2/3, that cancels it out. Then we're going to take the 8 and we're going to divide it by 2/3. We're going to do 8 divided by 2/3. 8 divided by 2/3 is going to come out to a positive 12. So you get x is equal to 12. Problem number 9. Here's my constant. My constant is a positive 3. The only way to get rid of it is to subtract 3 from both sides. I'm going to subtract 3 from both sides. Those 3's are going to get canceled out. I'm left with x over 5 is now equal to a negative 11. Instead of dividing, I'm going to go ahead and multiply. So we're going to multiply both sides by a positive 5. I'm going to multiply by 5, multiply by 5. The 5's are going to get canceled out, and we're left with x equaling a negative 55. Problem number 10, I need to identify my constant. My constant is a 6. The opposite of a positive 6 is to subtract 6. So we're going to go ahead and subtract 6 from both sides. That leaves us with a negative 4x is now equal to 20. Negative 4x is now equal to 20. We're going to go ahead and divide both sides by a negative 4. 20 divided by negative 4 is going to come out to a negative 5. Negative 5. Problem number 11. My constant is a positive 5. So I'm going to subtract 5 from both sides. The 5's are going to get canceled out. 11 minus 5 gives me 6. So we have 6 is equal to 3a. We're then going to go ahead and divide both sides by 3. The 3's will cancel out, and we'll get a is equal to a positive 2. Okay, last problem, identifying my constant. My constant is technically a negative 11. That minus 11 acts like it's a negative 11, so the opposite is a positive. So we're adding 11 to both sides. The 11's will get canceled out. You're going to get negative 4/5 w is equal to 24. You now want to go ahead and divide both sides by negative 4/5. Okay, by doing so, the 4/5 are going to cancel each other out. W is now by itself, and you're going to get negative 30 as your answer. You have an IXL that has been loaded on to Google Classroom. Go ahead and get on there and get it completed.